This is problem number 10 from section 1.3. In this problem it says, solve for the angle theta where 0 less than or equal to theta less than or equal to 2 pi. So that means theta's got to be between 0 and 2 pi. So we have sine 2 theta plus root 2 cosine theta equals 0. And we need to, because we have two different sine functions, in order to solve this, we're going to need to make one of these sine functions into the other. Or we need to, so we either need to make sine into cosine, or we need to make cosine into sine, one of the two. But you'll notice that cosine just has theta with it and sine has 2 theta. Because sine has 2 theta there, that's a double angle formula. So that kind of lets me know that I could probably start out using a double angle formula. And when I look at the double angle formula, I can see that that would change it into 2 sine theta cosine theta. So it doesn't quite change into a cosine, but it does include a cosine in the formula. So because it includes a cosine in the formula, you're going to see that we'll be able to factor out cosine and do some work with it. So we're going to take 2 sine theta cosine theta and we're going to plug it in. So 2 sine theta cosine theta plus root 2 cosine theta equals 0. And then we're going to go ahead and factor out the cosine theta like I talked about. So we're going to take cosine theta out. So we get cosine theta. And what's left is just 2 sine theta. And then plus root 2 equal 0. You can see now, although I didn't change the sine into a cosine or a cosine into a sine completely, I am now in a spot where I have the zero product property. So this actually gets us to a spot where we can solve it. Because I know that with the zero product property that cosine has to equal 0 or 2 sine theta plus root 2 has to equal 0. So I can say that cosine theta equals 0 or 2 sine theta plus root 2 has to equal 0. So cosine 0 equals cosine theta equals 0 or 2 sine theta plus root 2 equals 0. I can subtract root 2 over. That gives you 2 sine theta equals negative root 2. And then divide by 2. And I get sine theta equals negative root 2 over 2. Or cosine theta equals 0. So these are my two options. What I need to do now is I need to look at the unit circle. And on the unit circle, we'll start with cosine 0. When is cosine 0? Cosine 0 at pi over 2, comma 3 pi over 2, right? 0 right there. And then where is, slide this over, where is sine theta equal to negative root 2 over 2? Well, sine is negative root 2 over 2. Sine is negative in quadrants 3 and 4. So sine negative root 2 over 2 is here, 5 pi over 4. And the other one is 7 pi over 4. So I'm going to write 5 pi over 4 and 7 pi over 4. So my solutions are pi over 2, 3 pi over 2, or 5 pi over 4, 7 pi over 4. Those are the 4 possible solutions for this problem because all of those are within the 0 to 2 pi range. Now I do want to point out, we used a double angle formula, right? We used a double angle formula, but because we didn't go the opposite direction where we went from this formula to a double angle formula, we didn't double the angle. The doubled angle was already in place before we started the problem, and they had already included that with the 0 less than or equal to theta less than or equal to 2 pi. So when you go this direction to a double angle, you would have to double that to be 4 pi. But when you go in the opposite direction where you're going from a double angle to just a singular angle, you do not have to double your region. Hope that makes some sense.